Hello, this is again Professor Lioubimtseva in GPY101 Sustainability and Place, and this is Lecture 2, Food for Thought. I will focus today on the way how changing trends in the dietary choices around the world impact our health and especially health of our planet. We will explore how global food systems are interconnected with global climate change. My presentation would pinpoint these 7 major ideas: climate change trends and scenarios, the impact of climate change on food production and food security, the impacts of food production on climate system and climate change and mobility of food and how mobility of food is contributing to climate change. I will also talk about global and national trends in the dietary choices around the world and their possible feedbacks related to the climate system. And finally, we will take some future outlooks and discuss why should we care and why should we make adjustments in our food choices. Man-made climate change or global warming has many devastating effects on many aspects of our life, and one of them is certainly agriculture. Food production has been attuned for many thousands of years to specific environmental conditions of various geographic areas. Today, these agroecological conditions are changing very quickly. Some areas, such as West Michigan, receive abnormal amounts of precipitation during a very short period of time. Others, such as American Southwest, experience unprecedented droughts or forest fires, like in California, Oregon, and Washington during the past 2 weeks. This drying effect on food production all over the world have many negative impacts on the world's agriculture. According to projections of the IPCC, the Intergovernmental Panel on Climate Change, the drying effect on food production under global warming scenarios by the end of the century could be quite devastating if the temperatures are higher, just 3.2 degrees centigrade compared to the pre-industrial level. The number of drying days in many parts of the world is going to be significantly higher. Those are the maps of projected dry days, as well as runoff, precipitation, and soil moisture under climate change scenarios. We know that these climate change scenarios would have dramatic impact on the way where we can grow crops, what kind of crops we can grow, and what would be their productivity. Based on the climate change scenarios for maximum temperature and precipitation, many parts of the world where we are growing today, crops such as wheat or corn or soy are going to shift quite significantly. So this map shows us the changes in the rain-fed maize yields. That would change quite dramatically by the middle of the century, and this is just in 30 years. Climate change already impacts food security of the world and is projected to have even more profound impacts on food security of many countries. So, what is food security? According to Food and Agriculture Organization, food security is a situation that exists when all people at all times have physical, social, and economic access to sufficient, safe, and nutritious food that meets their dietary needs and food preferences for an active and healthy life. According to World Food Programme and Food and Agriculture Organization, food security components include food availability, food stability, food access, and food utilization. Food insecurity is really the absence or lack of food security. And according to the US Department of Agriculture, food security can range from high security to high food insecurity with hunger. This map developed by the UK Meteorological Office shows us hunger and climate vulnerability index in different parts of the world, as well as the percentage of undernourished population in different countries. And you can clearly see lots of spatial correlations between the areas in the world that are already significantly food insecure, and at the same time they are experiencing devastating impacts of climate change on their agriculture. As those impacts of climate change on agriculture are projected to increase, unless we succeed in mitigating climate change really as soon as possible and focus on cutting our emissions within the next 15-20 years, the impact of climate change on agriculture in those areas due to heat waves or forest fires or abnormal amounts of precipitation, tropical storms would further devastate this food insecurity to the degree that some parts of the world can simply become non-inhabitable, causing huge migration and huge flows of refugees around the world. This map shows us the rate of food insecurity here in the United States, where over 49 million people live in food insecure households. In fact, I suspect that these numbers are much higher because this map was produced before COVID-19 affected our economy. And so again, I want you to look at the geographic pattern of this map and see where we see the highest rates of food insecurity, particularly in the southern states. We know that those are the same people who are already extremely vulnerable due to the socioeconomic situation, who are now even more vulnerable due to COVID-19, and they are more vulnerable and will be more vulnerable to impacts of climate change and further deterioration of food insecurity in many parts of the country. I'm going to use the next few slides to explore with you what the world eats, and we will look at the graphs prepared by the National Geographic Project, What the World Eats, based on the statistics from the Food and Agriculture Organization. So we're going to see on each picture the percentage of daily calories coming from different types of food, and we are also going to look at the quantity of food in grams, again coming from different types of food for the world and for different countries. And let's take a note of what are those major components on our diet and how they differ around the world. So our first place is India, a country with a very high percentage of food insecure population. This is also a country with a very large population and fast-growing population, and is projected to surpass China and become the largest country in the world in terms of its number of people. Let's take a look at what is the staple of the national diet here and where the daily calories and the daily grams are coming from. Let's take notes. In addition to the statistical pie charts from the National Geographic, I'm also going to use pictures from the book by Peter Menzel, Hungry Planet, What the World Eats, to illustrate what is the typical set of groceries for a week by a family in each country that we are going to visit through the graphs. From India, we are going to East Asia to visit Japan. What do you see here in terms of the daily intake of calories and the total amount of food and the proportion of different types of food compared to India and compared to the average world numbers? And again, here we have a snapshot of weekly groceries thanks to the book of Peter Menzel, Hungry Planet. From Japan, we are going to China. This is the largest population in the world. So how does the Chinese typical national diet looks in daily calories and in daily grams? And what are the major staples of this diet? And here is our week of groceries in the Chinese family. Now we're going to visit Mexico, and again, let's pay attention of what are the staples of its national diet in terms of their daily calories intake and different proportion of different types of food in the typical national diet. let's also pay attention on the total intake of daily calories compared to what we saw in India, in Japan, and in China. And here is again an illustration of the previous graph showing us the typical supply of food for a family in Mexico. Our next country is the United Kingdom. So again, let's see what is the typical diet of an average British person, where the daily calories are coming from, what kind of foods are the major components of this national diet, and also what about the quantities of food. So how these food intakes in UK are compared to what we saw in India, in China, in Japan, and in Mexico. And here is our snapshot of weekly groceries for a typical British family. Our next graphs show us the situation in the United States. What is the number of calories consumed by an average American, and what is the total amount of food? And again, let's see what types of food are typical for our average national diet. And here is a typical supply of groceries in an American household from Peter Menzel's book. So what do you see from these pictures and what do you see from these graphs? Did you observe any trend as we moved from India through Japan to China, to Mexico, to UK, to the United States? What do you see in terms of different components of diet, in terms of the differences in the amount of calories in the average national diet, and also the overall quantity of food and quantities of different types of food? So I'm leaving this for the discussion. We will have the discussion on the blackboard, and I hope to hear from you your thoughts based on these pictures and based on these graphs. Our industrial meat production and dairy are extremely carbon intensive. According to Food and Agriculture Organization, total emissions from global livestock are 7.1 gigatons, and this is approximately 14.5% of all man-made emissions of greenhouse gases. Cattle, both beef production and dairy, and inedible outputs such as manure and draft power represent about 65% of all livestock sector's emission, and feed production and processing and enteric fermentation from animals are the two major sources of carbon emissions, representing respectively 45% and 39% of total carbon emissions in the world. Commodity-wise, beef and cattle milk are contributing 41% and 20% respectively of agricultural emissions of all greenhouse gas emissions. So let's now go back to our notes about various national diets and see how the percentage of meat consumption has been changing all around the world during the past 50 years. So in places such as the United States, the meat consumption has increased, but it was already quite high in the 1960s, and since that time it has increased by approximately 34%. There have been also a slight increase in some European countries such as UK. During the same time, the meat consumption in Russia has increased by 68%, despite a short period of decline in 1990s that followed collapse of the former Soviet Union. Due to economic globalization, we see westernization of diets in many parts of the world. In Japan, meat consumption has increased during the same period of time by 79%. And in India, which is the second largest population in the world, and a traditionally vegetarian society, meat consumption rate has increased by 71%. These numbers are even higher in Vietnam, where meat consumption has increased during the same time by 266%. And finally, in China, the largest population in the world, the meat consumption rate has increased during the same period of time by staggering 1,170%. Let's talk about it more in our Blackboard discussion this week, talking about the reasons and what these numbers really mean. But today, I really want to focus more on what these numbers mean for our planet's climate. Let's think of this data in the context of simultaneous global trends that are happening right now. First of all, we see the increasing vulnerability of our agriculture and food production and our farmlands due to devastating impacts of climate change. This is especially true in already food insecure regions and food insecure countries around the world. Second, we see the change in diets all around the world, with growing consumption of meat requiring more space, producing more carbon emissions, and reducing carbon sinks to produce more meat at the expense of areas covered by forest and other natural types of vegetation. Third, we see further globalization of our food system, increasing traveling of food around the world and growing food miles that are sources of carbon emissions on their own. And finally, we see the population growth. We are already over 7.7 billion people on this planet right now, and we are projected to see the population over 9.7 billion people by the middle of the century. Food is increasingly transported from far away, and this is another area where our food system is so much interconnected with climate system and climate change due to economic globalization. If you go today to do your groceries in Myers or any other supermarket, it would be probably quite an investigative journey to find out where different ingredients in your food are coming from and how long they have traveled before they actually reached you at the local supermarket. So an average US household consumes about 11 pounds of food per day, according to USDA data, and the average final delivery of food is approximately 1,020 miles. So the total supply chain required movement of approximately 4,200 miles, and this is on average. In some parts of the country or in some parts of the world, this can be significantly longer. Food groups vary in these average distances from low distance travel, such as for beverages, to very high distances for red meat, where the delivery is on average 1,800 kilometers or 20,400 kilometers as the total. So think of these numbers, and we already know that red meat is responsible for the highest carbon emissions due to the ways how this meat is produced. But we also have to add and factor carbon emissions associated with transportation of this meat from production to consumer. I spoke earlier about carbon footprints of different types of food, but considerable part of carbon emissions is also associated with transportation. In fact, 17% of carbon emissions related to food are associated with delivery and final distribution. So I want to introduce also the concept of food miles, and food miles are the distance our food is traveling from where it is grown and produced to where it is purchased and consumed. And carbon footprints associated with food miles are related both to the distance but also to the means of transportations that are used to move the food from the producer to consumer. So it is obvious that eating local food is great not only for our health, it's much fresher, much healthier food, it supports local economy, but also local food systems are very supportive for the environment and for the climate system because they help us to reduce this food mile carbon footprint. You're already familiar with carbon footprints of different groups of food, and so here again, if we compare different groups of food, not only in terms of carbon emissions associated with their production, but also with their food miles, Again, we see that out of all these groups, such as beverages and cereal and chicken and dairy and fruit and oils and red meat, when we compare them either non-normalized or normalized by expenditure or by energy content or by mass, the greenhouse gas emissions associated with red meat far outpace any other type of food. And so this is clearly a food for thought for us, showing how increasing consumption of meat is one of the leading causes of carbon dioxide emissions from our agriculture. Some closing thoughts for the discussion. Climate change drastically impacts our agriculture and food security, and it is increasing food insecurity in the most vulnerable regions, affecting the most vulnerable populations all over the world. At the same time, population growth and globalization are drastically increasing demand for meat. This increasing consumption of meat is leading to growing livestock production and growing greenhouse gas emissions from agriculture that are contributing to climate change. Food traveling is also contributing to climate change because as the food miles are growing, we see the growth of carbon emissions associated with food travel. And finally, I want to emphasize that changing consumer preferences might be the only way to slow down those vicious circles between accelerated anthropogenic climate change and globalization of our food system. I hope to see you online in the Black Box discussion. Let's continue this conversation.